In this video, we're going to take a look at simplifying the product of two radical expressions. Again, we can only multiply radicals or combine them into one radical if their indices are the same. So let's take a look at our first example. Here we're taking a square root, and here we're taking a square root. So we can combine this into one radical expression. And I'm going to keep my numbers separate, but I am going to put a multiplication sign between them just so that I know that they're still being multiplied. So 72 times 10, I'm going to keep under my radical like this. Now I'm going to multiply x cubed by x, and we know that we add exponents when we multiply a number or a variable with the same base. We add our exponents. Our y's are the same, so when we multiply, we will add their exponent, so that'll be y to the fifth. The next thing I'm going to do is, since I'm taking the square root, I'm looking for groups of 2. So let's start factoring 72 and 10. 10 is easy. 10 factors down into 2 and 5, but 72 factors down into 2 and 36. And 36 factors down into 6 and 6. So I'm not going to factor my 6's anymore because I have a perfect group of 2 here. And if I factored them down, I would just get 2 groups of 2 that would equal 6 when I pulled them out. So I'm going to keep it like this. Now I am looking for groups of 2 because I'm taking a square root, and I have some nice groups of 2 right here. So I'm going to pull one of my 6's out and one of my 2's out, and when I multiply 2 times 6, I get 12. But I have a 5 that needs to stay under my square root. So I'm going to write it here before I forget it. Now I'm taking the square root of x to the 4th. So if I put 4 and divide it by 2, I get 2 with a remainder of 0. So I can pull 2 of those x's out. And then y, I have 5 divided by 2, which is 2 remainder 1. So I can pull 2 of those y's out, but one of them has to stay under my radical. The next thing I do is I notice that I'm taking an even root, so I put absolute value signs around whatever I pulled out, and then I go ahead and simplify. Do I really need those absolute value signs? That is already a positive 12, so we'll just make it a positive 12. Here I have a squared x and a squared y, and we know anything that's raised to an even power is going to be positive no matter what value the variable has. So I actually don't need absolute value signs for this example. This is my simplified answer here. All right, so let's take a look at example 2. We're going to take the square root of 45x to the 5th y cubed times 35xy to the 9th. So let's go ahead and combine them under one radical sign. We are not going to multiply the 45 and the 35 because we just have to factor anyways. But when we multiply our x's, we get x to the 6th. 5 plus 1 is 6. And when we multiply our y's, we get y, 3 plus 9 is 12. All right, so let's go ahead and factor our 45. Our 45 factors down into 9 and 5. 9 factors into 3 and 3. 35 factors into 5 and 7. So we have a nice group of 2 3's here and a nice group of 2 5's here. So when we pull them out, 3 times 5, we'll take 1 out of each group. 3 times 5 is 15. Now we have a 7 that is remaining underneath our radical. So let's write our radical here. And we'll write our 7 here so we don't forget it. So how many 6's can we bring out? 6 divided by 2, not 6's, x's. How many x's can we bring out? Since we're taking a square root, we'll divide our exponent by our index, and we get 3 with no remainders, remainder of 0. So we can pull 3 x's out. That's awesome. How many y's can we pull out? Well, we've got 12 y's, and our index is 2. So that is 6 remainder 0. We can pull 6 y's out, and we have none that need to stay under a radical. So we only have one thing left under a radical. But we need to notice that we were taking a square root, so everything that we pulled out has to be put in absolute value signs. So now let's see what we can pull out of our absolute value signs. Our number's positive, so we can pull that out. And the only variable that has an even root is our y, so we can pull our y out. But our x cubed has to stay within our absolute value sign. So this is the answer right here. And we're finished.